Just check this works. Yes, there we go. Morning, everyone. My name is Lizanne Smit. I'm a hydrogeologist at GEOS, based just outside of Stellenbosch and Techno Park. And I form part of a multi-year project to look at groundwater within the Hortgro growing areas. So just briefly, today I'm obviously going to focus on the pome fruit areas, although some areas overlap. But just to start off, these areas are mainly in the higher rainfall areas of the Western Cape, but obviously as you move inland, you can expect a bit more summer rainfall and just a general decrease in rainfall. For the type of aquifers you're abstracting, for most of the growing areas, they're all on hard rock fractured aquifers. Although some growing areas like the Breede have thick enough sand deposits where you can actually have abstract from the sand aquifer, and some areas overlap where you have both. There we go. Sorry. And then qualities, generally good quality areas, but as you move further away from these Table Mountain sandstones and you're moving into the Langkloof and the Karoo, you really need to focus on where you want to drill, because there the quality can be poor if you're drilling in the wrong formation. The focus of the purpose of the research, just because globally groundwater actually makes up a much higher percentage of global freshwater than what rivers or streams and dams actually present. And then also with rainfall patterns changing, groundwater is actually less vulnerable to seasonal rainfall change, but it's poorly understood. So that's why we did the study. The methodology was desktop-based, and we focused on WARMS, which is all registered water uses, and NGA, which is just borals that are uploaded and the data is available, but we looked at geology, hydrogeology, aquifer vulnerability, climate, etc. Quickly going to go through these growing areas. Piketberg, on top of the Piketberg Mountains, lovely thick sandstone deposit from the Table Mountain group, high rainfall, so actually very high groundwater availability. There's not a lot of borals, but they're all situated very close to each other, so the water levels are a bit deeper than what we'd like, so obviously we'd encourage monitoring there, but overall a lot of groundwater availability. The Woolsley-Tilbach area, you're going to see this in the few areas where the mountains next to the valley are these thick Table Mountain sandstones, and then as you move into the valley, you actually have the younger Bokkerveld group, which is more shale-rich. So quality is poorer within the valley area than on the slopes of the mountains, but you can target borals, especially around fractures, where you can still get high yields. But this is an area where water levels range a lot, and as well as yield. So you can have a dry to a quite strong boral in that area. Ceres is a very big area. There's a lot of groundwater abstraction, very interesting geology. Depending on where you site, you can also have a very high yielding or a very low yielding boral. Best borals are drilled normally also in the TMG, but you can also find higher yielding within the Witteberg and the Bokkerveld group as well. Somerset West, there's not a lot of groundwater abstraction here. People mainly use the river, the Lawrence River that runs through, but here you do actually, the yields aren't that high, but you can target weathered and fractured areas within the granite and the shale, and there's actually also a primary aquifer within the sands in this area. The Elgin-Grabouw area, actually quite high rainfall, very interesting geology. So from here onwards, it really depends on where you want to site your boral. But there's some lovely syncline valleys. There's formations that host a lot of groundwater. Generally, water quality is very good. So this is definitely an area that if you site the boral correctly, you can actually get high quality and high yields. Rivier Sonder End, this is an interesting area. The quality actually, it's the best in the western area, and then it decreases slightly as you move east. Very dependent on geology, so again, it depends on where you site the boral. There's not that much groundwater abstraction currently this area, And water levels from here onwards to the Langkloof you can expect are slightly deeper. That's just the general trend, which is fine. And yields, the general yield is low, but there are some very high yielding borers in this area that specifically target fractures. The Langkloof West area, not a lot of groundwater abstraction here. It's also a syncline valley. There's actually some high yields within, especially the TMG. So this is an area which hasn't historically used a lot of groundwater, but there is actually a high potential to get high yields if you site the borers within specific geological formations. Langkloof East, slightly more or a bit more groundwater use in this area. Again, the yields can go from dry to 11, so it depends very much in what geological unit you're targeting. And in these areas, you might actually find a very, the formations aren't that thick. So you actually, if you're drilling a 200-meter borehole, you can drill through the Bokkerveld and try and target one of the TMG formations, which will give you a much higher yield. Just overall, most sites, we did a aquifer firm yield model. So basically, of all rainfall that falls, what percentage goes into the groundwater. It just looks at vertical recharge, so not lateral recharge coming from outside of your growing area. So it basically showed most areas as positive. Some, Breda, Woolsley, Ceres, and Piketberg showed a negative one, but it's vital to note that these are all areas being surrounded by mountains with a very high or much higher rainfall and those TMG sandstones. So we actually do suspect lateral recharge in this area, and that's why monitoring, especially in these areas, are critical to ensure that what you're doing is sustainable. Then there's a lot of areas that showed just a positive balance. A lot of these areas don't have that much groundwater abstraction currently. And with appropriate borehole siting and careful management, this is a good area to invest in using groundwater. Then we also did Afrikaans and English brochure on groundwater guidelines and groundwater management. And they really focus on the entire life cycle of groundwater, so from siting through to licensing and monitoring. And it's basically just to increase awareness and best practices within the groundwater sector, within the agricultural sector. So these are just a few images pulled from the brochures, and it just touches on how important logging of boreholes are. So the driller goes away and you don't know where the fractures are, it's going to impede you from managing that borehole for the next 20 years. So it's vital to get that drilling information if you're drilling a new borehole. Then it's also vital to use the right type of testing. So there's various ways to test a borehole, but we always say use the South African standard. So it's published, and I think it's just good best practices to, when you're testing a borehole, to say, please test it according to this, because when you're licensing the boreholes, DWS and the other officials will also want you to test it according to that. The different types of flow meters you can use, type of monitoring data and what it can provide to you, so how it can show if you're maybe pushing the borehole too much or if you can actually use more. And the type of infrastructure you can install into your borehole, which is just best practices within the industry. And with 50 seconds to go, the take-home message is just groundwater is a sustainable, cost-effective water supply solution, but success depends on careful planning before drilling. And key aspects are linked to required versus expected yield and quality. If you know the geology and the conditions within that area, you're really going to target according to that rather than just where's the closest area to the power sector, but you'll target for the best yield and quality, and you'll also know what you can expect for that area. And then just to look at the full life cycle, which includes site selection, smart drilling, scientific yield and quality testing, the getting your water use authorized, equipping it based on the test results, and monitoring treatment, and storage. And then just the last point is just to treat groundwater as a valuable shared resource that it is. Thank you.